In addition to fungi, bacteria, and archaea, animals in the soil are also important components of the decomposition of organic matter. Soil animals influence decomposition by fragmenting, transforming, and transporting litter, grazing populations of bacteria and fungi, and altering soil structure. This is a pretty long sentence in the book, but it's important because it shows the three different things that soil animals do. First, there's that decomposition, because they fragment, they transform, and they transport litter, but they also have important effects by grazing populations of bacteria and fungi, and we'll talk about that too. Lastly, they alter soil structure, and this can't be overlooked for their importance in the decomposition environment. Working our way up in size, the microfauna are the smallest of the animals. These are often less than 0.1 millimeters across. Nematodes, protozoans, and rotifers are considered to be microfauna. Many of these microfauna are predatory on bacteria and don't actually directly decompose plant litter, but are important for recycling nutrients and decomposing, in essence, the bacteria and fungi that are present in the soils. Slightly larger than microfauna are mesofauna, and these start to be a little bit more recognizable. They range in size from 0.1 to 2 millimeters, and these are often fragmenters of litter and hold a very important component to the decomposition cycle. So, for example, collembola are an important mesofauna. And these collembola do a lot of different things, such as fragmenting litter, chewing it up, and making it smaller and more accessible to smaller organisms. Lastly, we have the macrofauna. And these are larger than 2 millimeters. So, for example, isopods are macrofauna, as well as earthworms and termites. Now, it's important to remember that microbes constitute 70-80% of the labile carbon and nitrogen in soils. And those organisms that turn over the microbial community, are important in grazing that community, are really important for making this labile carbon and nitrogen available in soils. So when they graze bacteria, for example, the nitrogen that's contained in that bacteria becomes available to other microbes as well as to plants. And a large proportion of the mineralization of nitrogen that's made available to plants comes by grazing these microbes.